All right, now that we've finished working with the distributive property, we should all be pretty comfortable with that. So we're going to start working with simplifying expressions. And simplifying algebraic expressions can be one of the harder things that we have to do in pre-algebra, but it's one of those things that we absolutely have to be able to learn and understand. It is one of the basic principles that we use for algebra and beyond in math. And so it's going to be one of those things that we're going to spend some time on, just like we did the distributive property. So let's take some notes. Here we have an algebraic expression. Let me zoom in for you. We have 3x plus 5 plus x plus 4. Remember, it's an expression because there's no equal sign. And we can just write that over here to the side to remind ourselves. Expression, no equal sign. Okay, we need to remember that an expression has no equal sign. So if we take a look at our expression, there are lots of vocabulary that we need to get down with this. So we're going to have a lot to write in here. Let's put a box around our terms. We'll put a box around the 3x, around the plus 5, around the plus x, and around the plus 4. So when we look at this expression has 4 terms. I'm going to write the word terms large in all caps because it is one of the vocabulary terms that we need to know. If you have your highlighter, grab your highlighter so that we can highlight some of the vocabulary. Okay, let's take our highlighter and highlight the word terms. And terms are just the different numbers or variables that are separated by an operation, like plus or minus. So the terms in this expression are 3x, positive 5, so we can just write that with the number 5, positive x, we'll just write that as x, and positive 4, so we'll just write that as a 4. So those are the 4 terms in this expression. The next vocabulary word that we need to know is like terms, and we've talked about like terms previously, working on our math minutes and working on distributive property. And so like terms in this particular expression are going to be 3x and x, because they both have the variable x, and 5 and 4, because they are both constants. And we'll talk about constants in just a minute. Remember that like terms, we'll write a little definition here for like terms. Like terms are terms that contain the same variable and constants. So here we have 3x and x, 5 and 4. The next term that we're going to look at is the term coefficients. And this is one you'll hear me talk about quite a bit as we move through pre-algebra. So let's go ahead and highlight the term coefficients. And coefficients is the number before a variable. In this case, we have 2 coefficients. One of them we can see really well, and I'll highlight it up here in the terms because here's the number 3. It comes before the x. But we have another one, and this one is an assumed coefficient. We don't see it, but it is assumed to be there because x is the same as 1x. Anytime you see a variable alone, there is an assumed coefficient, and that assumed coefficient is 1. So our coefficients for this term are 3 and 1. The last term that we want to discuss, or vocabulary word that we want to discuss, is the word constants. We talked about that a little bit when we discussed like terms up here, but constants, those are a term without a variable. If it's a constant, it can't change, okay? It doesn't change. So term without a variable, and here we have two terms without variables. We have 5 and 4. Let's look at some examples. In number 1, we have an expression, and we're going to go ahead and put a box around our terms so that we can make sure we know which ones are positive, which ones are negative. And then we also want to remind ourselves out here that y is the same as 1y. That'll help us whenever we're starting to talk about coefficients. So the terms for this expression are going to be 5x, 3, 5x, and y. So we have two 5x's here, so they will both be terms of this expression. Next, let's identify the like terms. And the like terms are going to be 5x and 5x. And then when you look up here, we've got a 3, which we know is a constant, and there are no other constants, so there are no terms like 3. And then we have a y, or a 1y, and we don't see any other terms with y, so there are no like terms with y. So our only like terms here are 5x and 5x. Coefficients. We need to look at our terms that have variables to determine what the coefficients are. We have 3 terms with variables, 5x, 5x, and y, or 1y. So we know our coefficients are going to be 5, 5, and 1. Don't forget that one, when the y equals 1y, so we have that assumed 1 as a coefficient. Our constants for this expression, we only have one number that is without a variable, and that is the number 3. So that is our constant. Number 2, let's put a box around our terms. We have 2m, negative n, and positive 6m. So we have 3 terms. We want to keep in mind that negative n is going to be the same as negative 1n. There's assumed 1 there as the coefficient. And because it was already negative, that is going to be a negative 1. So our terms are going to be 2m, negative n, don't forget that subtraction out here is going to make that negative, and positive 6m. Those are our terms. For our like terms, we have 2m and 6m. There are no other terms with an n in it, so there are no terms like negative n. For our coefficients, we have 2, negative 1, and 6. 2 is the coefficient for 2m, negative 1 is the coefficient for n, and 6 is the coefficient for 6m. Looking at our expression for constants, if we look at the different terms, we have 2m, negative n, and 6m. We have no terms without a variable, so our constants are none. Don't write 0, write none. And our last example, let's put a box around 4y, minus 2x, and minus 7. So we have 3 terms. 4y, negative 2x, because that subtraction there, if we use our same opposite rule, makes that a negative 2x, and negative 7. Like terms, when I look at my terms, there's one with a y, one with an x, and one with a constant, so I have none or no like terms. My coefficients are going to be 4 and negative 2 because the 2 in front of the x is negative. And then our constants, we have one term without a variable, and that's going to be negative 7. Okay, let's move to the next page. You have some practice problems, so I want you to take just a couple of minutes, pause the video, work those practice problems, and then because of the amount of time this one is taking, I want you to bring those practice problems back to class tomorrow, and we'll go through them together. Okay, you should be back from working your practice problems. Let's look at the next key concept. An algebraic expression is in simplest form if it has no like terms and no parentheses. When you use the distributive property to combine like terms, you are simplifying the expression. So let's take a look at these. In our examples, number 1, we have 6a plus 2a. Remember, I can only add them if they are like terms, and because they both have an a, I can add them. So 6 plus 2 is 8, and then we leave the variable a with that. Be careful not to think that this is going to be a squared. When we add them, we leave the variable the same. Number 2, we have 3 terms again. So let's go ahead and put boxes around our terms. Plus, we have a positive x, a positive 9x, and a positive 3. They're already grouped with like terms, so we don't need to group them. We just need to take our x plus 9x, and we get 10x, and then plus 3, because we have one constant. And 10x plus 3 is the answer. They're not like terms, so we can't add them. Look at number 3. Let's put a box around our terms, 6c plus 4 plus c plus 8. So the first thing we want to do is box our terms, and then we want to group like terms. Okay, so to group like terms, we're going to take 6c plus c, because that's what it says in the box, plus 4 plus 8. Once we've grouped them, then we can simplify. 6c plus c is 7c, because remember that there is an assumed 1 with this c. Plus 4 plus 8 is plus 12, so 7c plus 12 is our simplified answer. Let's look at the next page. We've got a couple more examples. These include not only combining like terms, but the distributive property, so they're going to be a little bit more difficult. So the first thing we have to do is take care of our distributive property. So we have x plus 3 times x plus 4y. So we'll take the 3 times the x and the 3 times the 4y. We get x plus, remember 3 times x is 3x, plus, because there's a plus in here, 3 times 4y. So we have x plus 3x plus 3 times 4 is 12, so plus 12y. To simplify them, we add our like terms. Remember, there's an assumed 1, so if I have 1x plus 3x's, I get 4x plus 12y. Number 5 is a little bit more difficult because it has this subtraction in it. So we have to be very careful and understand that that's going to make this a negative 3. So I'm just going to put my finger over that 5 for just a minute. I'll put the 5 out here, but then I'm going to take negative 3 times y plus negative 3 times 7. Negative 3 times y is negative 3y, plus negative 3 times 7 is plus negative 21. Now, once we get it to this point, we need to group our like terms. So we've got, let's put boxes around them. We've got a positive 5 a negative 3y, and a negative 21. So we have 5 minus 21 minus 3y. 5 minus 21 minus 3y. So we know we've got a negative 3y. Let's just put that here. And then we take 5 and we subtract 21, we get negative 16. That one's a little bit harder to do, so if it's hard for you, we need to really pay attention to our integer rules. Next, you have some practice problems. Once again, I want you to pause the video, work the practice problems, bring them in tomorrow so that I can give you credit for them, and we'll work them together in class. Once you're finished, come back to finish the lesson. Okay, the next section is translating verbal phrases into expressions. I'm going to go through these with you, but we'll spend some time on these in class as well because there's a lot of things that we have to think about. So the first problem says you have saved some money. Your friend has saved $20 more than you. Write an expression in simplest form that represents the total amount of money you and your friend have saved. Well, we know when it says total amount of anything that we're going to add something. And it wants us to add the amount of money that you have and the amount of money your friend has. So one thing that we see and we can highlight says you have saved some money, but we don't know how much money. And if you remember in algebra, anytime that we have something that we don't know, we're going to name it a variable. So let's call the amount of money that you have saved X. And then we know your friend has saved $20. So an expression that would represent the total amount would be your money plus your friend's money, or X plus 20. The second one says you bought 5 folders that each cost X dollars, a calculator for $45, and a set of pens for $3. Write an expression in simplest form that represents the total amount you spent. Okay, there's a lot to think about with this one. So if we bought 5 folders that cost X dollars each, we know that that's going to be 5 times X. So here's our folders. We bought a calculator for $45. And we bought a set of pens for $3. Now, we want to know the total amount that you spent, so we know that means we're going to add. So we're just going to take this and say 5x plus 45 plus 3. But we have 2 like terms here that we can add together, so we get 5x plus 48 as our answer. Take a minute, try to work the next problem, enter the practice problems, bring it to class tomorrow so that we can work on it together.